Well, welcome back. Today we're going to explore some angles a little more in detail, and we're going to talk about specific types of angles. So our objective today is to identify special angle pairs and use their relationships to find some angle measures. So to start off with, we are going to look at some angle pairs. In this example, you see angle 1 and 2 and angle 3 and 4, and we're looking for a type of angle where there are two coplanar angles with a common side, a common vertex, and no common interior points, and those are called adjacent angles. Adjacent angles. They share a side, they share a vertex, but they don't share any common points inside. And those are adjacent angles, so make sure you understand what an adjacent angle is. The next pair we're going to look at, two angles whose sides are opposite rays. So you'll see angles 1 and 2 and angles 3 and 4. And those are called vertical angles. Vertical angles, they form kind of a letter V here. That might be a way to remember that. Thirdly, we are going to talk about angles whose measures have a sum of 90 degrees. And those are called complementary angles if they add to 90. So angles 1 and 2 add to 90. And angle A and B, if you add those together, they also add to 90. And then looking at the last angle pair, two angles whose measures have a sum of 180 are called supplementary angles. So if they add to 180 or form a straight angle, then they are called supplementary angles. Here are some problems to try to identify some angle pairs. It says use the diagram at the right, and is the statement true, and if it is, explain. Well, this one says angle BFD and angle CFD are adjacent angles. Is that true or false? BFD and CFD. Well, that's actually true because they don't share any interior points. They do share a common side and a vertex. So those definitely are adjacent angles. This one says, how about angle AFB? So AFB, this one right here, and angle EFD. It says, are those vertical angles? Well, when we look at those, they are not opposite rays, okay? So those cannot be vertical angles because they don't form straight lines, the two pairs, so they are not opposite rays, so they are not vertical angles. And how about the third one? It says angle AFE and angle BFC. AFE and BFC. Are those complementary angles? Well, remember, complementary angles add to 90. And if you add 62 and 28, it looks like they do add to 90 degrees. So yes, those are definitely complementary angles. Here are a couple for you to try. I think this would be a good place for you to pause the video and see if you can answer these on your own. Okay, I hope you had a chance to try those on your own. This one says angle AFE and angle CFD. So AFE and CFD. Here's AFE and CFD. Are those vertical angles? Well, it kind of looks like in the diagram that they are. Since they have opposite rays, yes, they're vertical angles. How about BFC and DFE? BFC and DFE. Are those supplementary? Well, if they're supplementary, they have to add to 180. And it does not look like they add to 180, so they are not supplementary. Are angles BFD and AFB adjacent angles? So BFD and AFB. BFD, AFB, and yes, those definitely are. They share a side and a vertex, but no interior point. So those are definitely adjacent. Hope you did okay on those. If not, make sure you ask me questions in class. Sometimes, just by looking at a picture, we can make some assumptions with our angles. Things that we can assume are adjacent angles just by looking at the picture. Not only can we assume they're adjacent, but we can also assume they're supplementary or they're vertical angles just by looking at the diagram. Things that we can never assume unless they are specifically marked in the diagram is that angles or segments are congruent, or an angle is a right angle, or an angle is complementary. Okay, those definitely have to be marked in the diagram. What can you conclude from the information in the diagram and explain each conclusion? Well, when you look at this right now you can tell angle 1 and angle 2 are congruent because they're marked. Okay, and it also looks like we have some vertical angles and some supplementary angles because we have some straight lines. So let's take a look. Angle 1 is congruent to angle 2. Angle 3 and 5 are vertical angles. See how these straight lines here, 3 and 5 are opposite. They form that V. So those are vertical angles. Angles 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 1 are adjacent angles. They're a whole bunch of adjacent angles. If they share a side and no interior points and a vertex, then they're adjacent. 3 and 4 and 4 and 5 are adjacent supplementary angles. That means they form a straight angle, 3 and 4 or 4 and 5, because they add to 180 degrees. And that is what we can assume just from looking at the picture. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles of a linear pair form a straight line. So in this example, well, let's just go ahead and take a look at what our postulate says first. If two angles form a linear pair, then they're supplementary. So in this example, angle CBD and ABD are a linear pair because they form a straight line. Angle ABC is a straight line. Find the missing angle measures. This one says, let me get this down a little bit further here, angle KPL and LJPL are a linear pair, and they tell us algebraic expressions for the two angle measures. What are the measures of angle KPL and JPL? Well, we know that these two form a straight line or a linear pair, so we can say that they add to 180, so we can start setting up an equation like we did before. The sum of the measures of the angles in a linear pair is 180, so the measure of angle KPL and JPL must add to 180. That's our starting point. And then let's substitute in for each of these angles what their algebraic expressions are. So KPL is 2x plus 24, JPL is 4x plus 36. Combining our like terms of 2x and 4x gives us 6x. 24 plus 36 is 60, and that's equal to 180. Remember, now we got to move that 60 over or subtract 60 from both sides, and we get 6x equals 120. Dividing by 6, we get x equals 20. And don't stop there. Once you find x, you got to plug it back in to the expression. Okay? So for KPL, 2 times 20 plus 24 gives us 64. And JPL, 4 times 20 plus 36 ends up giving us 116. And if you add those two together, you should get 180 degrees. If you don't, then you've made a mathematical error, and you should go back and see if you can find where you went wrong. Here's another one for you to try. Angle ADB and BDC are a linear pair, and the measure of angle ADB is 3x plus 14, BDC is 5x minus 2. What are those two angle measures? Well, here's our starting equation. Substitute in those algebraic expressions, combine your like terms, and then simplify. Subtract 12, divide by 8. X is 21, plug it back in. You get 77 for ADB and 103 for BDC, and they do add to 180. An angle bisector is a ray. Okay, you see this ray AY right here is an angle bisector, and it divides angle XAZ into two congruent angles. Its endpoint is the vertex, and within the ray, a segment with the same endpoint is also an angle bisector. So, and we already talked about in this diagram, it's ray AY. That tells us that angle XAY and YAZ are congruent. Or if you see on a diagram that those two are congruent, you can assume that AY is called an angle bisector. So here's a multiple choice question. Using an angle bisector to find angle measures. It says AC bisects angle DAB. If the measure of angle DAC is 58, what is DAB? Well, the first thing we want to do is draw a diagram. So we have this angle DAB with an angle bisector of AC. DAC is 58 degrees. They told us that. So we want to find DAB. We want to find the big angle, the whole thing. Well, this one's pretty straightforward. So by definition, angle DAC is 58 and it's congruent to angle CAB. But the big angle is equal to the sum of the two angles, right? CAB plus DAC. And we already know that those are congruent. So 58 plus 58 gives us 116, which is answer choice D up here. So D was the correct answer. All right, here's a quiz for you to take. Make sure to put your name at the top up here somewhere, usually on the top right here, before you turn this in. You can do this at home and turn it in when you get into class tomorrow. I'll be collecting that. See you next time.